So in the last video, we covered simple electron configuration for most atoms in the periodic table. Now in that episode, I said the electron configuration for gold would be Xe for 4 xenon, then 6s2, 4f14, and then 5d9. This all makes sense, and this follows the filling order according to the Aufbau principle. More on that, check out the previous video where I cover the correct order, where it goes 1s2, 2s2, 2p6, 3s2, and so on and so forth. Although this does follow the rules presented in the Aufbau principle, this does not actually reflect the real electron configuration of gold. If you go on to a Google search and search up the noble gas configuration or the noble gas electron notation for gold, it would be Xe for xenon, 6s1, 4f14, and 5d10. Last episode, I told you guys that the electrons go into a specific order. And although they do follow roughly the same order here, there's now 1 electron in the 6s orbital and 10 in the 5d orbital. The reason for this is that orbitals each have a sort of stability level. Last time, how it was covered was that we were taught about a partial and a full. Obviously, we want to make all of our orbitals full before moving to the next one because they're more stable whenever full. So the fullest ones are going to be the most stable, while the partial ones, or the partially filled, like let's say a 5d9, are going to be unstable. But there's a little in-between state, half. A half is going to be more stable than partial, but less stable than full. We can compare the rest of these 3 orbitals, the 6s, the 4f, and the 5d. In this case, if you look at the first one, you have 2 full, that being the 6s and the 4f, and 1 partial. For the second case, you're going to have 2 full, the 4f and the 5d, and 1 half. Note that the maximum capacity of the s block orbital is 2. So therefore, having 1 electron here would make it half full. So in this case, you can see that the overall stability of this electron configuration is better than this one up here. Now let's look at the electron configuration for chromium. If we write it in noble gas notation, we see that argon is the previous noble gas. It will then go on to the 4s2, followed by the 3d4, right? Because it's 1, 2, 3, 4 elements into the d block. Now whenever we're looking at this, we see that it has 1 full orbital, the 4s, and 1 partial. We know that it's partial because the maximum capacity a d block can hold will be 10, and 4 is not half of 10, and it's not completely 10, therefore it's partial. If you can see here, there's a obvious way that we can make this more stable. We can write it as argon 4s1, 3d5. So these two sums are still going to be the same, this adding to 6, this adding to 6, but there's now going to be 5 electrons in the 3d orbital, and there's only going to be 1 in the 4s orbital. Why is this the case? Because once again, this has 2 half-filled orbitals, which is going to be overall better than 1 full and 1 partial. The final way to represent an electron configuration is through an Aufbau diagram. Let's say we have carbon. We know that the electron configuration for carbon is going to be helium, 2s2, 2p2. Now, if you write this out in its full form, 1s2, 2s2, 2p2, we notice that each of these orbitals are going to have 2 individual electrons. Well, what we can do is that we can separate them into a more telling graphic. I'm going to draw a square here, and I'm going to label this 1s. Another square, 2s, and 3 squares in a row, all of them combined, called 2p. If you don't recognize what I'm doing here, I am grouping these up into their maximum capacity divided by 2. Since the s block can hold at most 2 electrons, I'm going to draw 1 square because 1 is half of s. Same thing with 2s, and for p, since the max can hold is 6, I'm going to draw 3 squares. Now for carbon, to draw the Aufbau diagram, you're going to start by regularly filling up the squares. What do I mean by filling it up? Well, instead of putting in a number here, we're going to put in arrows, an up and then a down. So each box is going to have an up and a down until we get to the P block. It may seem that we have to fill up all of these squares, but instead each one of these arrows represents 1 electron. So these two are represented in this square, these two are represented in this square, and the last two have to be represented somewhere in these 3 squares. Now there's 2 ways that you would first think of doing this. One way is to have them up down, like it is intuitive to do, but instead you're going to have one up and the next one up. You are only ever going to draw a down arrow whenever all of the adjacent squares are going to have up arrows. Why is this the case? Well, the electrons don't really like each other. You heard that opposites attract, so the same charges would like to repel, negative and negative. In this case, electrons want to be as far as they can from each other. This is the case where we actually do get these orbitals, just because of electron repulsion. In this case, we don't want to group electrons close together because these two do not want to be close. They want to be in different little shells. So, if you were to practice this and go with something like gold, once again, in this case, I'm not going to draw out the full thing, just the noble gas. So gold would be xenon 6s1 4f14 5d10. Remember, because instead of 2 and 9, this one jumps because full and partial. I mean full and half. So if I were to draw the Aufbau diagram for this one, I would do xenon. And then for an s, since the maximum it can hold is 2, I'm going to draw 1 square because that's 1/2 of it, 6s. Since f holds 14 at the max, half of that is 7. So 1, 2, 3, 4, 5, 6. So that should be 7. 1, 2, 3, 4, 5, 6, 7 for F. And D would have 5. 1, 2, 3, 4. Now, let's start with 4F14 first, because that's pretty simple. Since it's fully filled, we're going to have an up, down, up, down, and we're going to keep on going. Sorry if it's a little messy, but all these squares should have an up, down, each representing two electrons per square. For the 5D, it's going to be the same thing, up, down, up, down, up, down, up, down, up, and down. And for the 6S, since it has only 1, even though it comes before, it's only going to have 1, it's not going to be completely filled. Let's try with sulfur. If I'm doing sulfur, and if I write down its electron configuration, noble gas notation, be neon, then 3s2, and then 3p4. So in this case, I can draw out neon here. It's s block, or it's 3s orbital, up and down. For its 3p, it can be filled with up, and instead of going up, down, we know that these electrons here want to be as far apart as possible, and therefore we're going to draw all the up arrows first. So up, up, up. 4 minus these 3 is 1, so we have 1 left over, so now we can pair them. Now you know all the exceptions and how to draw electrons in an Aufbau diagram. Note that some of these exceptions do have other exceptions of their own, and it's always good to do a quick Google search of an electron configuration. This is just a guide and is meant to give a basic understanding of how and why electrons act like the way that they do. Thank you for watching, and I hope you enjoyed.